PN junction diode 100 forward bias. Reverse bias is later. Okay. Today we discuss only the forward bias. Now reverse bias next week. Okay. I think you have a lot of time. That's why you go to take separately. And today PN junction diode 100 forward bias to study the characterization of PN junction diode. That is the aim of the experiment. I think lower classes you study, you know very well about what is PN junction diode. Is it correct? Yes? Say yes or no. Hey, what about PN junction diode, ma? What about PN junction?
Yes, sir.
So that is P-type semiconductor and N-type semiconductor connected base to, okay. So you get PN junction. So once the junction is formed, okay, whether depletion layer is formed or not?
Yes, there is a depletion layer.
Yes, there is a depletion layer between the PN junction. Now, the PN junction is connected to forward bias. So what is the meaning of forward biasing? Anyone?
The P-type is connected towards the positive terminal of the battery, and the N-type of the semiconductor is connected towards the negative terminal of the battery.
Okay, very good, very good, very good. So, P-type is connected to positive and N-type is connected to negative. Due to this, what about your depletion region, width of the depletion region? Increase or decrease?
In forward, I guess it decreases.
Yes, correct. The forward
In
bias.
forward, it decreases, and in reverse, it increases.
Yes. So forward bias, why that the width of the region decreases means P is positive, N is connected to negative. N, the majority charge carries electrons, P side majority charge carries holes. Both are like charges. So definitely the repulsion between the holes and electrons is there. So due to this, your width of the region goes on decreasing. Once and the applied input voltage exceeds the barrier potential, the width of the region completely disappear. Is it correct? Yes? Are you understand this or not?
Yes, sir.
Yes. So that time, there is no region. What about electrons and holes? So easily cross the junction. So due to this, the diode is conduct. So that is the forward bias characterization. See here, once the depletion layer is disappeared, the free electrons from the N-type region can easily drift to P-type region and the holes from P-type region to N-type region in the crystals. Hence, ideally, there will be no obstruction of flowing the current, and the PN junction behaves like a short circuit. The current will flow through the external circuit. So inside, the electrons and holes crossing the junctions. Externally, in the output, you get the EMF, or the diode will conduct. So that is the PN junction diode characterization. Okay, understand? Yes. Say yes or no more. Say yes or no.
Yes.
Yes. Okay.
Yes, sir.
Okay. Now, you just wait. I show the characterization PN junction diode video. Yeah, others mute the mic. Others mute your mics here. I think some disturbance is there. Yes. I think there's some disturbance is there, ma. Okay. Okay. Say just wait. I go to share the video. So please, all of you go to listen the video first, please. Yeah. Say Drive is visible for you. Google Drive.
Yes, sir.
Yes. Okay.
Very good morning to all.
Just wait.
The diagram is exactly like between conductor and insulator. Generally, you know, we will discuss what are the experiment. First of all, we will discuss the characteristics of PN junction diode. What are the PN junction?
Now, what about audio?
This is a PN junction.
So it is not clear. It's getting
Lagging, sir.
Wait.
First, what is a PN junction diode?
Now it is coming,
PN
wait.
junction diode is formed when a P-type semiconductor
Is it okay now?
to an N-type semiconductor.
Okay, you just listen
Potential
for 5 minutes.
Potential barrier voltage across the diode junctions. This is a PN junction diode. The PN junction diode is characterized as zero bias, reverse bias, and forward bias. First, we will discuss them one by one. In PN junction diode, there are two operating regions and three possible biasing. The three possible biasing condition for the standard junction diode, and these are is a zero biasing. There is no potential, and a forward bias. The forward bias is a positive terminal is connected to the positive. There is a terminal. There is a positive diode junction. Positive is connected to a positive voltage terminal, and the diode negative is connected to the negative terminal. This is a forward bias. And a reverse bias. The reverse bias there, then the positive is connected to the negative, negative is connected to the positive. First, we will discuss our laboratory. What are the characteristics of PN junction diode under the forward biasing? What is the aim? To plot the characteristics curve of PN junction diode in forward bias. What is a forward bias? The positive terminal is connected to the diode positive, and the negative terminal is connected to the diode negative. This is a forward bias circuit diagram. The forward bias circuit diagram consists of following apparatus. It is a voltmeter, it is a ammeter, it is a forward bias terminal input voltage, it is a regulator voltage regulator. This is a PN junction diode. It is everything is a inbuilt. First of all, what is the procedure for the characteristics of PN junction? What are the characteristics of PN junction diode under the forward biasing? For forward bias of a PN junction diode, the P type is correct. P type is there is a positive terminal is connected to the positive terminal, and N type, that is a negative terminal is connected to the negative terminal of the battery. That is a P is a positive and N is a negative. And there is some forward voltage. What the germanium is a 0.3 volt and the silicon is a 0.7 volt. The potential barrier is altogether eliminated and the current starts flowing. This voltage is known as threshold voltage or cutoff voltage or knee voltage. It is practically same as the barrier voltage. Generally the barrier voltage is used as V suffix B. For V is less than VH, that is a V is less than TH, that is a threshold voltage, the current is negligible. As the forward bias voltage increases, that is the input to the forward bias increases, beyond the threshold voltage, the forward bias current rises exponentially. When a VEF, that is a V, that is a volt VF, that is a increasing. What happened beyond the threshold voltage? What happened? That is as the forward voltage is increased beyond the threshold voltage, the forward current is rises exponentially. This is a procedure for characteristics of PN junction under forward biasing. Now, first of all, there is very well. This is a connection. First, you know very well. This is the positive terminal P. There is a positive terminal here. The positive terminal is connected to the milliammeter. The positive terminal is connected to the ammeter. It is a milliampere, microampere. This is a switch on. That is a milliammeter. Towards the milliammeter, sometimes it is a microammeter. But we are using only milliamps. And the negative terminal is connected to the voltmeter negative. The guys are connected to the voltmeter negative. And the another one point is connected to the negative terminals. Next, this is a voltmeter positive. This is a diode positive is connected to the voltmeter positive, and diode negative, this is diode negative is connected to the voltmeter negatives. Okay, this is voltmeter negatives. Now switch on, what happens? Now is a switch on, that is a input current, that is a 0 to 3 volt. The operating voltage is a 0 to 3 voltage. Now the input voltage is adjusting, this is a regulator power supply. Yeah, we fix the first initially is a 0.1. Is a 0.1 volt. How much of ammeter reading? 0.1. That is a 0. 0.1. That is voltage is a 0. Again increasing the input voltage 0.2. 0. 0.3 also 0. Yes. Now 0.5. Yes. Or 0.1. Yes. No. 0.4 is a no 0. Next increasing 0.5. Yes. 0.5. How much current is flowed the circuit? For 1.5. That's the forward voltage is a 0.5 and forward current is a 1.4 or 1.5 is a 1.5. Is a 0.5 is the forward voltage and forward current is a 1.5. Again increasing 0.55. 0.55. How much of current flows the circuit? There is a diode. Ammeter reading is shows clearly 3.5. 0.55. 3.5. Again increasing 0.6. So 0.6. How much of current is flowed? Developed the diode 8.8. Again increasing. Yes, 0.65. How much is produced? How much current flows is developed? 18.7. Okay, what is the loading objective from the tabular column? When a forward voltage is increasing, the forward current also is increasing. Beyond the threshold voltage, what happened? That is what happened? That is the forward current is rises exponentially. Okay, there is a 4 or 5 reading is enough. Based on this value, we should draw the graph. Based on the observed values, the graph is plotted. See, the graph plot is point I use is a 0.5, 0.52, 0.54. For example, if possible, 0.5, 0.51, 0.52. The x-axis, that is the scale is a 0.02. But you will fix the 0.005, that is the curve is a very smooth and exponentially finally. Okay, this is a graph for the PN junction diode under forward biasing. Finally, the result, the PN junction characteristic is studied and the graph is plotted. The graph is plotted.
Yes.
Very good.
See, all of you listening? Okay. I think almost all of you watch the video, full video. Yes. See, all of you watch the video or not? Yeah.
Yes, sir.
Yes, sir. Yes, sir.
Yes. Yes.
Yes, sir.
I think now you understand how you go to take that experiment. Yes. Say yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. See, the forward bias, I think the sir explained, okay, how you make a circuit connection. That is very simple. Okay, the positive and the PN junction, just wait. I share the one more assignment screen, just wait. See, just wait, I will come. Yes. Yeah, the screen is visible for you. Say yes or no more. Assignment screen is visible or not?
Yes, sir. It was good.
Yes, sir.
Yes. Okay. See, that aim already you sir explained. That is, you go to see what is the to study the forward bias characterization of the PN junction. That's all, very simple. The circuit is also sir is explained very well. Okay, that the PN junction connected to forward bias. How that the P side goes to connected to positive and the N side goes to negative, like that he explained very well. And the voltmeter is connected across the PN junction diode, and this is the corresponding characterization curve. So in the graph, you get the curve like this. Okay. So now once you go to the connections, how you go to take the reading? I think sir explained. If you increase that amplitude button, the voltmeter reading increasing, the corresponding ammeter reading you go to note down in a milliammeter. Okay. So the readings are given here. See here. The forward bias, the forward voltage, and the corresponding forward current is also given in the tabular column. See that 0, your current is also 0. Then the 0.2 voltage is 0.2 volt. The corresponding current is also 0. And the 0.4 volt, you get 0.5 milliampere current. Then 0.6, 0.8, 1.2. So up to some total readings are there here. The corresponding current in ammeter you go to note it down. So based on this, you go to draw the characteristic curve. That's all. Okay, by using these readings, how you go to draw the graph? So V along the x-axis and I along the y-axis. See here, V along the x-axis and I along the y-axis. So what is the scale you go to choose in the x-axis? Anyone? Scale. Very simple.
0.2.
Yes, 0.2. Take 0, 0.2, 0.4, 0.6, 0.8 like that. Okay. And what about y-axis? Y-axis up to 25 is the maximum reading. So you have to take 2, 4, 6, 8, 10 like that. 2, 4, 6, 8, 10. Or if your graph sheet is very big graph sheet, you take 1, 2, 3 also. Take 1, 2, 3, 4, 5 like that. Up to 25. Okay. Then you based on that, you draw the graph. So by using the reading, both the readings that V and I, you go to draw the graph. That is the assignment. So that's why I'm telling this is very simple experiment. So by using the readings in the tabular column, both V and I, to draw the VI characterization curve. That's all. Then you write the results. No, nothing is there. No calculation. Nothing is there. Okay. Understand?
Yes, sir.
This is compared to last week. This is very, very simple experiment. Okay. See, last week is 4 graph, but this week only 1 graph. So by using that V and I, by using the V and I, that the forward voltage and the forward current, you will draw the forward characterization curve. This curve. That's all. The experiment is over. Any doubts here? Any doubts?
No, sir.
See that this is characterization kit that available in the kit is available in the laboratory. That is junction diode characterization kit. So everything is inbuilt. You simply switch on the device, increase the amplitude. For each input voltage, you go to measure the output current. That's all. So each and the most of the practicals in the laboratory is the kit. Okay, inbuilt kit. Your experiment is very, very, very easy. It will take maximum 5 to 10 minutes for take the readings here. That's all. Okay. Yes.
Yes, sir.
Any doubts here? Any doubts here? Any doubts or anything else?
No, sir.
Say yes or no more. Any doubts or anything?
No, sir.
No, sir.
Okay. Then I go to share this assignment in the GCR. Okay. At least you go to take time, 4 or 5 days, because now almost all of you celebrating that Diwali. Okay. So next week you go to submit these things. Okay.
Okay, sir.
Understand?
Yes, sir.
Yes. Any clarifications or doubts? Anything else more? Any clarifications or any doubts regarding this experiment?
No, sir.
No. Okay. I think then I go to take the attendance. I think 65 students are there. 64. I think 7 students are absent, missing. Nikhil. In that practical already informed no absentees, but in your class only the most of the students they are absent. Yeah, practicals. I don't know why. But why they are absent? So okay, anyway, give your attendance first. 51. What about 51? Atul Gupta is not there. 52.
Yes, sir.
53.
52 present, sir.
53. It's not there.
53 is
54.
also not there.
Present, sir. 54 present, sir.
Okay. 55.
54 present, sir.
Okay.
Present, sir.
57. 57.
Present, sir.
It's not. Okay. 58.
Present, sir. 57.
Okay. 58. 58. 59.
Present, sir.
60. 60 more. 60. Janavi.